Hi, my name's gwEm and welcome back to my YouTube channel. So a few months ago I did a video which explained how you can use a 1970s Yamaha synth like my CS5 with the modern Korg step sequencer, the SQ-1. And I showed two methods, one with a direct analog connection and one using a MIDI converter. And the idea of using the MIDI converter was that it allows you to get much lower notes than was possible with the direct analog connection. But I've since found a way of getting the full range from the CS by using an analog connection, so you don't need to buy a slightly expensive MIDI converter. What you do need to construct the adapter is a 1/4" mono jack, a length of cable. I've just used an old guitar patch lead, and a 1/4" mono socket. And inside there is a 1K8 resistor and a 3K9 resistor. So I'll take you through how to make that and I'll give you a demonstration of how it works. Alright, so let's take the converter apart so you can see how to make your own. So we'll start with the socket end. Now this is the simpler part of the converter. All that you need to do on this end is simply solder your cable into the socket. So the core of this cable is going to the tip of the socket, and the screen is going to the screen of the socket. Now the other end is more complex. You need to solder in a couple of resistors, which you can see here. So between the core of the cable, which is here, and the tip of the jack, you need to solder a series resistor, and this resistor is 3.9K. And you need to solder another resistor, this one here, which goes between the tip of the jack as well and the screen of the cable, and that resistor is a 1.8K resistor. Okay, so we're in the studio and I'm going to demonstrate the conversion cable that I made. So I've just got the CS5 here and it's just plugged directly into the mixer. So the first thing I'm going to do is tune it, and I've got this Boss guitar tuner for the tuning. So I'll play a C. And it's around there, and I'll just play a few other notes just to check the linearity. Very good. So now I will plug in the SQ-1, which is behind it. Here is the adapter. The connections I'm going to make are the CV input of the CS5 into this converter cable, and then into the CV out of the SQ-1, and the gate out of the SQ-1 will go into the external in of the CS5. Now you need to first of all press the function button and make sure that it is set to 8 volts hertz per volt here. Right? That's a key. And if you're using the B channel, you can do the same. Instead of having the duty turned in a clockwise direction, you want to make sure that it is turned all the way anti-clockwise, so it's on the minimum. Right? Then we can press play on the SQ-1, and we don't hear anything because what we have to do is adjust the trigger level. And then your trigger level will give you your duty, if you like. I want to play just one note, which is this low C in order to demonstrate to you that the tuning is now correct on the CS5 and we can get those low notes. So that's the low C. Let's bring back the Boss tuner. And as you can see, the tuning of the low C on the SQ-1 is indeed exactly in tune with the C there. And if I disconnect all this and play that note on the CS5, you'll hear it's in the same octave. So there you go. The converter is giving us those bass notes that sound so nice from the CS5, but playing from the SQ-1. Let's play a slightly longer sequence on the SQ-1, and I'll mess a bit with the CS5 so you can see that it's able to play pretty good bass. I'll re-enable all those steps. So there you go. That's a much better way of connecting the SQ-1 into 70s Yamaha CS synth. You get the full range and you can play some bass lines on it, which is obviously what you want to do with an analog mono synth. So I hope you consider liking the video and maybe even subscribing to my channel. I'll see you in another video soon, and if you stay on the video, there's a little bit of bonus content for you now. Take care. Alright, so some bonus content now explaining how this all works. So in the 1970s, when Korg was making synths like the MS-10 and the MS-20, they used a CV system which was in hertz per volt. And Yamaha also used a hertz per volt system. Which is why on the SQ-1 you can still play the Yamaha and have it be in key. Although the difference between Korg and Yamaha is the starting point for the scaling, which means you can't get the low notes on the Yamaha when you plug it into the Korg. So with Korg, the lowest C that you can play is 1 volt, and the next one up is 2 volts, and it keeps doubling basically, so you have 4 volts and 8 volts for the higher Cs. Now that is completely different on the Yamaha scaling. So I did some measurements myself, and I found that this middle C, when I played it on my Yamaha, gave 0.63 volts, which got me thinking. You need to reduce the voltage when you go from Korg to Yamaha, so you don't need to have any kind of active components. So you can do this simply with some resistors. So I figured out the values that you need. 0.63 divided by 2 gives you 0.315. So we want to make a potential divider which will give us this scaling. So the input is the Korg voltage. That's going into one resistor where we take it to the Yamaha, and we go into another resistor and into ground. Now I've called this resistor resistor A and this resistor resistor B. Right? You take the total resistance A plus B. You know this is 0 volts. You know this is, in this case, 2 volts. So you set the resistor values such that this will give the 6.3 volts. So there's a simple formula, which is the resistance of A divided by the resistance of A plus B, and that gives us something that I'll call F, which is this factor, which is this one here, right? A is equal to F A plus B, simply multiplying both sides by A plus B. We can multiply out this expression here. Then we can subtract FA from this side, which gives 1 minus F times A, which is FB. So we can swap the 1 minus F and the B to give us A over B equals to F over 1 minus F. So we can plug in this value for F, which is 0.315, and that gives us A over B is 0.46. Now, when you get resistors, they come in certain specific values, which are in a series which they call the E series. And you can't just get particular values that you want, you have to work with what they give you. So I used an online calculator to try and find a value for A over B as close to 0.46 as I could. And the best that I found was A is equal to 1.8K and B is 3.9K. And this will give you A over B is 0.462, which is extremely close. And it means that you can play the keyboard on the Yamaha and then plug in the SQ-1, and the difference in tuning, if noticeable, is only about a cent. Now I wanted to check that the Korg would be able to drive this circuit with no problem. So you can do a simple bit of Ohm's law. So this 3.9K plus the 1.8K is 5.7K. We know the maximum voltage is 8 volts. So you can simply divide 8 by 5.7K, which gives us 1.4 milliamps, which I felt the Korg would easily be able to drive. Now I wanted to keep these values quite low because this is, as I said, a passive network of resistors, so you have to first of all, not to put too much load on the Korg by having these resistors too low. So we should be okay there with the 1.4 milliamps that this draws. But at the same time, if you make these too high, which would reduce the load on the Korg, what can actually happen is that the components in the Yamaha will create a non-linear scaling, because they will then be significant compared to these two resistors. Now, I actually checked that, and I don't know if this is good design on Yamaha's part or not, but the CVIM basically goes directly into the VCO chip with no buffering. So I figured that the input impedance of the Yamaha is probably around 1 to 10 meg. So these numbers are very low in comparison to that. And you get linear scaling across the entire range from C0 to C3. So there you go, a little bonus content about how that works.